Lesson now. Okay, so today, as we said, atomic structure. Let me just share my screen. One second. Okay, so yes, atomic structure and its chemical reactions. So first of all, what is chemistry? Okay, so think about it. Maybe shout it out. What do you think chemistry is when you first hear the word?
The study of chemicals.
Sure. Write something in the chat or study of molecules and particles. Yes, that is somewhat right. Branch of science that looks at chemical bonds and structures. It does look at that. Yeah. Okay. So to be specific, or actually to not be specific, it is the scientific study of properties and the behavior of matter. So that's like the overarching, phrase to describe chemistry. But in simple terms, it is the study of composition of matter. And I think someone said that. So in chemistry, we study reactions, interactions, changes, transformations, properties, physical and chemical changes, all of that. We also see how things combine and, you know, how they process and form new substances at times. Yeah. So we'll go over the branches of chemistry with this video.
Branches of chemistry. There are many types of chemistry. Here, we will discuss major types of chemistry and their uses. Ever watched a mystery series in which the detective recovers an unidentifiable sample from the scene of the crime and runs it through a series of tests? This is what comes in analytical chemistry. Analytical chemistry. Analytical chemistry is the study involving how we analyze the chemical components of a sample. For example, how much caffeine is there in a cup of tea? Are there drugs in an athlete's urine samples? Examples of areas using analytical chemistry include forensic science, environmental.
Is HelloFresh worth the price? Absolutely.
I was doubtful too, until I realized I was actually saving money by cooking HelloFresh.
For example, this week I ordered a
For example, how much caffeine is there in a cup of tea? Are there drugs in an athlete's urine samples? Examples of areas using analytical chemistry include forensic science, environmental science, and drug testing. Analytical chemistry can be divided into two main branches: qualitative and quantitative analysis. Qualitative analysis employs methods and measurements to help determine the components of substances. Quantitative analysis, on the other hand, helps to identify how much of each component is present in a substance. Both types of analysis can be used to provide important information about an unidentified sample and help to identify what the sample is. Biochemistry. The fact that sweating cools the skin is a function of strong forces of attraction between water molecules. Our body maintains blood pH because of an elaborate bicarbonate buffering system. The mad cow disease in humans is caused by a misfolded protein. Does this give you a clue about what biochemistry is? The study of chemical processes in living organisms is called biochemistry. Everything in the body is made up of atoms and molecules of different chemical compounds, like carbon, oxygen, and hydrogen. This is what we study in biochemistry. Biochemistry can further be divided into interesting disciplines like enzymology, which is the study of enzymes, endocrinology, which is the study of hormones, clinical biochemistry, which is the study of diseases. Molecular biochemistry, which is the study of biomolecules and their functions. Organic chemistry, the study of carbon compounds such as fuels, plastics, food additives and drugs. Organic chemistry deals with the study of carbon and the chemicals in living organisms. An example is the process of photosynthesis in a leaf because there is a change in the chemical composition of the living plant. Have you ever wondered who makes your hair conditioner or the drug you take when you have a headache? Organic chemists are the ones who do these. They devise experimental methods to isolate or synthesize new materials and study their properties. Would you like to be an organic chemist in the future? The branches of organic chemistry involve many different disciplines, including the study of ketones, aldehydes, hydrocarbons, and alcohols. Inorganic chemistry. Would you like to know how our Earth forms gold? This is what inorganic chemists do. Inorganic chemistry deals with elements and compounds other than carbon or hydrocarbons. It covers all materials that are not organic and are termed as non-living substances. Those compounds that do not contain a carbon-hydrogen bond. Compounds studied by inorganic chemists include crystal structures, minerals, metals, catalysts, and most elements on the periodic table. Industrial chemistry. Industrial chemistry is the branch of chemistry which applies chemical and physical processes towards the transformation of raw materials into products that are of benefit to humanity. Nuclear chemistry. While the common perception is that nuclear chemistry involves only the study of radioactive nuclei, it is much more interesting than that. Nuclear chemistry is the study of the chemical and physical properties of elements as influenced by changes in the structure of the atomic nucleus. Modern nuclear chemistry, or radiochemistry, is now very interdisciplinary in its applications, ranging from the study of the formation of elements in the universe to the design of radioactive drugs for diagnostic medicine. Which of these branches interest you the most?
Okay, guys, we're gonna move on to atomic structure. But before we do that, I just wanted to say, as you can see that video, there's so many different applications of chemistry. Chemistry is a really cool subject, and once you get into like higher grades, you'll start to do experiments, and you start to explore like applications of chemistry in real life, and you'll find a lot of cool things. So, yeah. Moving on now to atomic structure. Atoms are the smallest unit of matter, and at one point, people thought that atoms are the smallest thing that you could find, except people found out later on that their atoms are actually made up of protons, neutrons, and electrons, and these are considered the smallest now. Protons are represented by the symbol P to the, I guess, superscript of the plus sign, and then neutrons are N with 0, and electrons are E with a negative sign, or so minus sign. Moving on, the standard atomic notation, or SAN, consists of the atomic number of protons on top, and the atomic mass, number of protons over the number of electrons plus the number of neutrons on the bottom. And then to receive the number of neutrons, you can therefore subtract 2. Each electron shell can fit 2 n to the power of 2 electrons, where n is the shell number. And so this is simplified to 2, 8, and 8. And this just represents how many electrons are each shell when you're drawing a diagram, for example, a Bohr-Rutherford diagram. And now we have a video to help explain.
Atomic structure. In this video, we're going to go over atomic structure in a very simplistic and basic way. Atoms are the basic unit of chemical elements. They contain subatomic particles in their nucleus and in the electron cloud that surrounds the nucleus. These subatomic particles include protons and neutrons, which are located in the nucleus, and electrons, which are located in the cloud or field that surrounds the nucleus. Protons have a positive electrical charge, neutrons are uncharged, and electrons have a negative charge. The number of protons and electrons are equal, so atoms are electrically neutral particles. If we look at a model of the element carbon, which has 6 protons, 6 electrons, and in most cases 6 neutrons, we can see the electrons in simple rings or shells surrounding the nucleus. Each shell represents a different energy level, and it can only hold a certain maximum number of electrons. In chemical reactions between atoms, only the electrons in the outermost shell participate in the resulting chemical bond. In atoms with only one energy level or shell, 2 electrons are required for stability. If we look at helium, which has only one shell or energy level, we see that it is full because it contains 2 electrons. So helium is stable, and there is no naturally occurring compound containing helium. Hydrogen, which also has only one ring or shell, possesses only 1 electron in its shell, so it's chemically reactive. In atoms with more than one energy level or shell, 8 electrons are required in its outermost shell for stability. So neon, which has 8 electrons in its outermost shell, is stable, and oxygen, which has only 6 electrons in its outermost shell, is chemically reactive. Atoms that do have fewer than 8 electrons in their outermost shells will try to share, gain, or lose electrons in order to become stable. This is called the octet rule, but there are some exceptions, such as we saw with hydrogen and helium, which have only one energy level or shell. And that be the basics on atomic structure. Atomic structure. In this video, we're going to go over atomic structure.
All right. So now that we mostly understand the atomic structure, we'll go over some chemical reactions. So first of all, what are they? So a chemical reaction is the process of a substance or more than one substance, also known as reactants, converting into one or more different substances known as products. And this can either be chemical elements or compounds that are reacting. And an example of this that you see in your daily lives is the rusting of metal. Okay, so we'll go over the types of reactions, but how many chemical reactions are there and can you name them all? So, write it in the chat. First of all, how many are there? And name them all. Okay. How many chemical reactions are there and what are their names? There are more than 3, or at least we'll talk about more than 3. There's more than 4 too. Okay, so as you can see, the number is pretty rough, but what we'll go over today is roughly 5 chemical reactions. And then in terms of naming them all, we'll go through that as we talk about them. So the first one is combustion. So this is a reaction between fuel and oxygen. And this is when oxides and water are produced. This is, so in specifics, a complete combustion reaction will produce carbon dioxide and water. And then an incomplete reaction will produce the above products, as well as carbon monoxide and carbon. And I'm sure all of you have learned this if you have taken chem, or even if you've taken science in grade 9 and 10. So this is, of course, for all combustion reactions, and it's just that the amount of fuel changes. And an example of a combustion reactions would be methane and octane. Okay, all right. Our next reaction is synthesis. So this is probably the simplest one that you'll ever see. Yeah, so synthesis is with the combination of two smaller reactants into a larger product, like sodium chloride. So while we're going through this slide, if you just want to, name a synthesis reaction that we use or see in our daily lives, go do that.
Plants.
Sure. What exactly?
Photosynthesis.
Yes, photosynthesis does have synthesis reactions. Um, so when you have less products than reactants, it's often a synthesis reaction. Uh, Again, rust and acid rain, and then I guess photosynthesis too. Um, our next reaction is decomposition. So this is the complete opposite of synthesis. It is when a larger reactant breaks down into the multiple smaller products. And if you look at how it sort of looks in terms of diagrams and stuff, it literally looks like that original, like this equation or whatever, was flipped to the other side. So you have AB on one side and then it breaks down into its reactants. So an example of this in our daily lives would be soda pop. So there are single displacement, sorry, no, okay. Here's a video about decomposition reaction.
My job, make college easier because students have a lot on their Sorry, Coach.
Oh.
All right. Hopefully that taught you a little something, and also why you should not be smelling different chemicals like that, because bad things can happen. Yeah. Do not do that. Do not do the stuff that that kid just did.
Okay, moving on to single displacement reaction. Single displacement reactions are basically when one element replaces another in a compound. Compounds are where you have multiple elements together. So in this situation, a metal will replace a metal and a non-metal will replace a non-metal. And the way the reaction works is if you have A is an element and BC is your compound, then A will replace B in the compound and will become AC plus A plus B. And common types of reactions of these types of reactions can be seen where potassium plus sodium chloride basically is happens in a single displacement reaction where you end up with potassium chloride plus sodium, and potassium and sodium are both metals, so they basically replace each other. And then in the other reaction, we have Cl2 and 2NaBr, and then you end up with 2NaCl plus Br2. Next, we have double displacement reactions. Double displacement reactions occur when both elements in a compound replace each other, and the metals and non-metals basically switch places with one another, where you have AB and CD as your compounds, and then AD, and then it ends up, then the B and D switch places, where you get AD plus CB. So for example, if you have sodium sulfate plus barium chloride, you're going to end up with sodium chloride plus barium sulfate, where the sulfate and chloride both switch. Next, and then next point is both of these reactions only occur with ionic compounds. So that's a key point to know. Okay, so that is the lesson for today. I hope you guys learned about chemistry and the wonders of chemistry. As I said earlier, as you get into older grades, you're going to learn a lot more complex stuff. For example, organic chemistry. It's much harder to explain, but hopefully we gave you a little sneak peek into chemistry. And yeah.
All right. So we will now go on break for 30 minutes again, but this time we are going to open up breakout rooms, and each breakout room will be named a different chemistry topic. So if you don't want to just, be sitting and doing nothing during your break, we would like you guys to, do some research on that topic with whoever's in that breakout room, and maybe come up with like a 2-minute presentation uh by the end of the break period. But you could also just not do anything if you don't want to, but we are giving you that option. All right. So I'm going to start making those breakout rooms. But for those of you who don't want to do anything, come back at 12, actually. Okay. Okay, so I still don't know how to do breakout rooms. So instead, what I'm going to do is I'm going to just send some topics, and then you can, in the chat, just say which one you want to do. Or if you don't want to do anything, you don't have to do anything. All right, so the first one that we're gonna do is moles and molar mass and everything in that topic. So if you want to do that, go see something in the chat. Or if you don't want to do that, okay. The other topic will be, sorry, it'll be the study of gases. Okay, so if you want to do that, say something. Uh, does anybody have any topics that they would be interested in, looking into for the next few minutes? Okay, so, all right. If none of you actually want to do this, that's okay too. If you guys just want to go and break. If you want to do this, you have two topics that you can look into, and then if you actually do something, we can talk about it after the break. But yeah. Uh, are you guys here or are you guys, eating lunch? Like, do you want me to play brain games or brain games? Okay. All right, so we still have like 12 more minutes in our break, so you guys can go do whatever you want, and then just please come back at 12 with the materials that you need for the slime. Yeah, I just made it right now and it looks really cool. So yeah.
Excuse me.
Yep.
Where do we post our picture for the Rube Goldberg machine? I don't have an Instagram account.
You have an email account that you could email to the Innovire email.
Yeah, okay, I'll do that.
Okay, yeah. Oh, also, everyone will need either a popsicle stick or like a fork or a spoon or something just to stir the slime with. Unless you want to use your fingers, but that is your choice. Okay, all right, I'm gonna ask everyone to start coming back now, just so that we can start on time, because today's activity may take a little longer, so I don't want to keep you guys late. Okay, all right, I'm gonna assume that everyone is back by now. Okay, if you're back, just say something in the chat. Okay. Yeah. All right. So I'm gonna show you what we're making today. Let me know if you can see. Okay, so I already made it, but we are making slime. Yeah. So I don't know if you've ever made slime. It's I think it's disgusting, but some people like it. But yeah, this is what we're making. So make sure you have your kits and all the extra materials right next to you, and we'll get started. Okay. So so first of all, everyone needs to take out the glue that is in their kit. So the glue may either look like this, or it could be a big bottle that looks like this. Okay, so just take that out, put it to the side, and you're gonna need the cup from yesterday. Okay, so it should be either the red or the orange cup, just one of them. And yeah, make sure you do not take the black cup because the black cup is for another day. So just either the red or the orange cup. Okay. You're also gonna need either like a fork or a spoon or something just to stir your slime with. And yeah, okay. So I'll wait like 2 minutes while everyone gets their materials ready and then we can start. Oh, yes, and you also need either cornstarch, and if you don't have cornstarch, we'll also do it with flour. So flour, dish soap, and water. And the optional stuff is the food coloring. I'm gonna use food coloring because otherwise it'll just be white, but that is completely up to you. Let me know when you guys have your materials. And feel free to turn on your cameras for this part just so that we can, see what you make. Also, has anyone ever made slime before or it's like a first time thing?
I've made slime, but not the same recipe. I used borax.
Yeah, so the issue with borax is that it is expensive, so we thought a cornstarch would be a better solution because we didn't want you guys to go buy borax and stuff. So yeah. And it should be similar, just maybe a different consistency. So this is the consistency you are looking for. All right. Okay. Can I use corn flour? Uh, I'm not sure if you can use corn flour. We can try it, but it may not work. I've never used corn flour before, so I don't know. Do you not have cornstarch or baby powder? Okay. Do you have regular flour? Yes. Okay, so go get regular flour, dish soap, and water instead. Because I don't know if corn flour will work. Yes, baby powder does work. So we'll be doing two recipes. So the first recipe will be with baby powder or cornstarch. The second one will be okay. How much cornstarch? Not much. So in terms of like tablespoons, it'll be like 6 tablespoons. So like 6 of these type of thing. If you don't have much cornstarch left, you can just make a smaller quantity too. But yeah, you're not going to need the entire box or bag of cornstarch. I'll wait like 1 more minute and then we can start. So actually, just a question, does anybody who got the kits have these big bottles of glue, or does everyone have a small bottle? Okay, small bottle. Okay. So if everyone has a small bottle, which anybody has a big bottle. Okay, it's okay. I'll do it with both. I think one or two people.
This was for the, this is why we got that big cup.
No, do not use the big cup. Do you not have the red cup from the other day?
We do?
No,
Well,
yeah,
I
so
do.
use the black cup, the big cup is for Thursday. So do not use it until Thursday. You're gonna use the red
Okay.
or the orange cup. Okay?
Okay.
All right, let's get started. Okay. So the first thing that you're gonna do is take out your glue. So I'm gonna use this one. So you may either have this, so this is a 2-ounce bottle of glue, or a 4-ounce bottle of glue. So for the 2-ounce glue, you're gonna put most of it in, not all of it. Leave like a little bit left. For the 4-ounce, you're gonna put half the bottle in. Okay, so I'll show you with the 2-ounce. Okay, so actually I'll show you with the 4-ounce. So you're gonna put most of it in. Sorry, half of it in for the 4-ounce. Just leave a little bit too. Yeah, so you should pour it out like
Half of the
that.
cup or half of the bottle?
You have the big bottle?
Yeah.
Yeah, half of the bottle.
Bottle.
Wait, which, wait, this or this?
You're gonna take the glue, half of the glue, and
Oh.
pour it in the cup.
Okay.
All right. So
Big
this is
bottle's
the,
supposed to be in because I don't have it.
sorry?
I don't have a big bottle of glue.
No. You can either use the big bottle or the small bottle. It's different for everyone.
Okay, so do I put all of the small bottle or half of the small bottle?
You put most of the small bottle, just leave like a little bit for later. Okay.
Okay.
All right. And you should have some glue in a cup. You can take out whatever. I'm gonna use a fork to mix it around. So, play with it, mix it, just see the consistency of the glue, just for you to feel. Okay. And now this is for the people who have cornstarch or baby powder. If you do not have cornstarch and baby powder, wait a little bit. Okay. So you're gonna take your cornstarch, and if you have a spoon, that would be better. But if you don't, that's okay too. You can just pour it directly. But I'm gonna do it with spoons. I'm gonna put like 1 spoon at a time and try to get that consistency that I want. So I put 1 spoon in, and then I start to mix. Okay. Just keep on mixing until all the cornstarch is gone. Okay. And when all that cornstarch is gone, I'm gonna add another spoon, and I'm gonna keep on doing that until I get the consistency that I want. Okay.
What is the consistency that you want?
Have you ever made slime before?
No.
Have you ever played with slime?
Yeah.
Okay, so that's like you're trying to look for that type of consistency that you've
Oh.
seen.
Okay.
What do you mean by half and half, Andre? Okay, I'm gonna add another spoon of cornstarch. Oh, so there is no like ratio for how much you need. I'm just gonna keep on adding it in until I get that consistency that I want. I don't have an exact ratio to use. It's just based off of how it feels. Okay, so I added 2 spoons of cornstarch and I'm starting to get what I want. So I'm gonna just maybe add 2 more and then I'm done. But yeah. Do not over add cornstarch either because then it may be a little rough to play with. Keep on adding in that cornstarch until you get what you want. Okay. Okay, so where's everyone at right now?
Starch.
Sorry?
How can we find out the consistency of slime?
Okay, so you're gonna pick it up with your fork or whatever, and it should be like this, where it's very slowly drops. Okay, it shouldn't drop too easily. If it drops too easily, add more cornstarch.
Okay, thank you.
Yeah, you want it to be slime-like, right? So mine is also still dropping too easily, so I'm gonna add a little bit more cornstarch. Okay. Is anyone done? Does anyone have that consistency that they want?
Yes, I do.
Do you have a camera, Rudra?
I have one, but it kind of doesn't work because I don't know. It just doesn't work with Zoom.
Okay, that's okay. So what is your consistency like? Can you describe it for
So,
us?
like when I bring it up, it's falling really slowly, and
Does it feel like slime?
yes, it does.
Okay, great. So now for the next step for the people who have glitter or food coloring or whatever, or paint, even paint works, um, you're gonna just drop a little bit in. So it depends on how colorful you want it. I do not want too much color. So I'm gonna add a little bit of this purple food coloring. Very little. 2 drops maybe. That should be enough. Okay. So now that I have my food coloring in, this is what it looks like. This is like light purple color. Yeah, and I think I have my consistency there. I may need to add some more cornstarch, but I will do that. Okay, so um, the people who are still doing it, continue to work on it. And for the people that don't have cornstarch, I'm gonna start helping you guys out. Okay. So for the people who don't have cornstarch, you guys are gonna need glue, water, just soap, and flour. Okay. Just give me 1 second. Okay. So what you're gonna want to do is, sorry, wait. Give me 1 second. Okay, so you're gonna want to add, if you have the half bottle, add most of that glue in. So
For the cornstarch slime, all we do is add glue and cornstarch and food coloring if we want to, right?
yeah,
Can we add borax if we want to make it better?
yeah, you can add borax or contact solution if you have that. Add whatever you want, and then just show us when you guys are done. Okay, for the people who are doing the flour, oh, okay. Here, I'll show you guys anyways. Gonna
Is
take your
this
glue.
enough? Is this enough glue?
Uh, sorry, I can't tell. Just point at like how far it is in your cup. Is this the half bottle or the full bottle that you use?
I don't know.
You have the big bottle. Yeah, okay, it's the big bottle. Yeah, you can add a little bit more if you want, but it's up to you how much you want to make. Okay, so I'm gonna put my glue in. Also, be careful not to eat this because this is not edible. I don't know if I have to say that, but yeah. Okay, dump all that glue in. And okay, so after you have that
At least
glue in,
this isn't as annoying as the
the dominoes,
dominoes. Yeah.
yeah, more fun too. And then once you're done and when you actually play with it, it gets messy, but it gets fun. Okay, so once you add that glue, you're gonna want to add the same, like an equal amount of water. So here's my water for it, and try to make it as much as glue, like equal amount. It's like a 1-to-1 ratio, if that makes sense. Then you're just gonna stir. It may seem very light, and that is because it's just water and glue, but once you add the flour in, it'll get a lot thicker. It should look and like kind of feel like milk right now, with just the glue and the water. Okay, and then after you have that glue and that water, you're gonna want to add um you're gonna want to add that food coloring. So I'm gonna add
Cream.
some, sorry?
Someone's looks like cream.
Yeah. So it's equal part water as glue. So Abrar, are you doing the water and the glue thing? It should look like cream or milk or whatever.
Yeah.
Okay, yeah. So then if you have food coloring, now you're gonna want to add that in. I'm gonna add like one, actually, I'm gonna add a lot of green food coloring because why not? And you're gonna just want to stir in that food coloring. Think that a little bit. So you're gonna put the entire bottle of glue, Vinitin. Stir in your colors. Yeah, okay. After that, you're gonna want to add, sorry, you're gonna want to add your dish detergent or your detergent soap. Um, so I'm just gonna go in and do it by feel because there is no set amount. So just put in just a little bit. So for those of you who have made slime before, the dish detergent does similar things than what the to what the borax and the contact solution does. Okay.
What's borax?
It is this special chemical that looks like flour or cornstarch that it does the same thing as cornstarch, but it's used in different recipes. So do you guys know what cornstarch does in like food and stuff? Has anyone ever like cooked with cornstarch? And just keep on adding.
Same one as you.
Um, I love using dish soap because the dish soap I love using dish soap because when you pour a lot at a time, uh, bubbles form.
Yeah, I don't like that because that just gets in my way, but yeah. Okay, so I'm gonna add in some flour. 1 tablespoon at a time, again. And you're gonna want to add that until you get like that right consistency. Okay, so
For the recipe that includes flour, all we
yeah,
do is add flour, water, and dish soap.
yeah, but you're gonna want to add it in a specific way though.
So, like, how do we add that?
Okay, so you're gonna first want to pour out your entire glue bottle, and then sorry. And then you're gonna want to add an equal amount of water, and then add whatever food coloring you want to add. After that, you're gonna add some dish soap, or sorry, dish detergent, and then right now what I'm doing is I'm adding a little bit of flour and just very slowly adding in the flour.
Okay, so first should I add the food coloring while the slime's still wet? Like
Yes.
it's still
Yeah, so you can
watery?
add the food coloring and then just mix it together.
Slime.
Sorry?
I finished my slime.
Okay. We're just waiting for everyone else and then we can move on. Okay.
Wait, orange slime.
You made orange slime?
I also made orange slime.
Yes, orange
made-
is the best.
I made
Nothing
red.
better.
I made red, but it ended up looking like pink.
Oh,
Okay. So once you're done with that, you can turn on your camera and just show everyone how much dish soap. So Andre, there's no set amount because the recipe that we're using doesn't show that. So it's based off of how it feels. The dish soap should be adding like texture to the mixture.
it looks so slimy and beautiful.
This is what I have.
Cool. Do you want to like take it out and show us?
It's still kind of thin, though. Yeah, very thin.
That's cool though.
I probably need more flour. I put in like 5 teaspoons.
So
I
once
need a lot. I need a lot more cornstarch.
okay, is everyone done now or you can spend like the next 15 minutes just, modifying it and adding whatever you need. And then we'll move on. How much cornstarch? Okay. Uh, Samara, are you using the cornstarch and the glue recipe, like the first recipe?
Like the recipe we're doing right now that we've been discussing.
Okay, yeah, so for the cornstarch one, you add like 4 or 5 tablespoons.
Okay.
You have to keep on adding it until it like, feels like slime.
Okay.
Okay, so this is my slime. This is that one, and then the other one looks like this.
Blue?
I made one blue and then one purple.
Which one do you like most?
I like the cornstarch one more just because it's easier to use. Like it's so the blue one is a lot more like textured and rough, right? It's hard
Yeah.
to with it. And then
I'm gonna put salt in mine so it's smooth and rough at the same time.
you put salt.
Yes.
So it's 4 to 5 tablespoons, right?
Yeah.
use glue for another activity?
No. So if you have any glue left, that's all for you to keep. So enjoy.
Best part of when you put dish soap is because on your hands, and when you're going to wash them, you don't need to put on soap because it already has soap in it.
I don't think that's why we have detergent. That may be, but I don't think that's actually the reason. So what I know, it acts as an activator. So
For the yeast.
sure. Are any of you in Tompkin right now? Grade 7 Tompkin?
Yeah.
Grade
Oh, no.
six.
It's a grade 6.
We're in grade
Tompkin.
6. Grade 7, Tompkin.
Grade
So
6.
do any of you have Mr. Jansma?
Yep.
Oh, Mr. Jansma?
Yeah.
I got,
He
yep.
is. Wait, were you in SciTech?
Yeah, we were all in SciTech actually. Most of
Cool.
Innovire.
Everyone
So
here
were
is in
you in Miss
SciTech?
Jackson's class? Because I heard Innovire started in her class, didn't it? Genius Hour?
Yeah, in Miss Jackson's class. Yeah, actually, our founder can talk more about that, Abdullah.
I'm pretty sure half the people in the meeting.
From Tompkin.
Sure.
Yeah.
Yeah.
do you remember
Other
Miss?
people didn't.
Do you remember Miss Perez?
Yes.
Yes.
we do.
Teacher on Earth.
We're still in contact with most of our teachers from Tompkin. Especially since we did start at Tompkin 4 years ago. So yeah.
It's finally starting to get a little thick.
Nice. Is that the
But
flower?
Same, but it's taking so long.
Yeah, the flower one is a little.
I don't know if it's worth it, trust me.
It's taking a million teaspoons.
This is a prank on someone. I don't know, maybe my mom or dad. You know,
At one point, I gave up measuring and started throwing corn flour inside the slime.
Yeah, I'm not even measuring. I'm just using my hands and throwing a bunch of flour.
exactly. That's what you should be doing. Now you're a professional.
I agree.
Yeah, because my spoon is covered in glue.
I agree with whoever said they. I agree with Arya.
Arya.
I agree with him. I just gave up measuring. I'm just dumping it.
I hope you guys realize that only 621 of Tompkin is speaking right now.
620.
Yeah, 620. I'm so dumb. 620 is better than 21 because it is.
20 is we're younger. We're 620 years old.
121 years old, so they're older.
And there'll be 721. Or we might be 721. Who knows?
Wait, we're not
Who
going to be
knows? We might
720?
age by 2.
Yeah, we might or might not.
We may or may not.
When we go to 7th grade, we age by 100 years.
Yes. Or 101 years.
Or you minus
or you'll just drop off.
Or you minus 99.
Oh.
Or you go back to being a baby.
Die. Bro, this slime looks so cool because I'm spinning my stick or my pencil in circles and
You're just putting a pencil in there?
Yes, I am. I'm putting a pencil.
Bro, you did 100 years. Bro, you put 100 years.
Yeah.
100 years of life.
100 years of life. Do you know how long that is?
People who can't speak
100. No, do you know how long that is? 50 generations.
What?
50 generations.
How? What does that mean? What are you
That's
trying
more
to say?
2 years per person. Then your future generations also have 2 years. So
Oh.
50.
I think most people do have 2 years.
Who knows? Let's find out.
Psychopaths don't because they rip their ear off.
So they can't listen to anybody. Because everybody's dissing them.
Yeah, Arnav, you're gonna become a psychopath
Why?
because everyone disses you.
Wasn't there
Ouch.
an artist? Wasn't there an artist that cut off his ear?
What?
What?
Oh yeah, yeah. What was his name again?
Picasso or
Vincent.
Leonardo? No, I think it was Picasso.
Picasso?
Picasso? Yeah, I think it was him.
Why?
Picasso cut off his ear? I don't
Oh,
remember
was it-
who it was, but there was a guy.
Somebody said it's Van Gogh.
Oh yeah, Van Gogh. Van Gogh? Wait, you
Yeah,
mean the
Van
person who painted the picture on your mask? Oh, that one.
Oh, what's it called? Starry Night. Yeah, Starry Night.
Yeah, Arya's mask. That's what I call it.
The picture painted on Arya's mask.
Yes, yes. The professional made
The professional made a
and
mask.
Arya Kinzorga would buy the mask for $2 and use it for like literally no reason.
It finally
Don't need a
kind of
mask
fit.
anymore.
Oh, mine's slime.
Does cornstarch activate the slime, or do you have to separately put in borax or something?
No, so the cornstarch is supposed to activate the slime in our
Okay.
recipe.
Okay.
Oh yeah, borax can activate it too. Also, if everyone is mostly done, we can end early today, and I think everyone's pretty much done. So feel free to log off if you want. Otherwise, you guys can stay here for a little bit if you want to chat. But yeah, we are.
Let's chat. 6:20 we'll chat.
Just before you guys end off today, a reminder that tomorrow we're going to explore biology and specifically
Yay.
genetics.
Yay!
We
So is there a
have.
recording for this meeting too?
Sorry?
Is there a recording for this meeting too?
Yes,
Wait.
there will be a recording for this meeting too. I'll
Wait,
email
aren't
the
we gonna do
link
biology?
to all of you later on.
We're doing genetics
Yes.
tomorrow.
I don't have any.
You don't have genetics?
Imagine,
You're dead if you don't have genetics.
but imagine someone who doesn't have genetics.
All right,
Then
guys. Sorry, wait. Before you guys say anything, tomorrow we actually have a proper expert who's coming in. So
wait, I thought you said that was for
Thursday.
yeah, we have
astronomy.
one on Thursday and one on tomorrow.
Cool.
Yeah. Okay, so get ready for that. So actually what we'll do is that we won't chat right now. We will log off. Yeah. So you guys can start to leave.
Okay, bye.
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 See you tomorrow.
Bye. Bye.
Bye.